The soil is not a mere container for our crops. It is a living, breathing entity. Well, it is the foundation of all life. When we ask if hybrid seeds harm this vital matrix, we must begin with a fundamental truth. The widespread monoculture-based cultivation of certain hybrid seeds, especially when coupled with industrial farming methods, alters the delicate web of life beneath our feet. Evidence from fields and laboratories shows the very design of these seeds can initiate changes in the soil's microbial communities, its structure, and its long-term fertility. This is not a simple transaction of seed for food. It is a complex ecological bargain, one that often leaves the soil impoverished, demanding ever more external inputs to sustain yields. We have been led to believe that productivity is the only measure of a seed's worth. To understand how hybrid seeds impact the soil, we must first understand what they are. A hybrid seed is the first-generation offspring of a cross between two genetically distinct parent plants. This process, known as hybridization, is controlled by breeders to select for specific desirable traits: high yield, uniform size, resistance to a particular disease. The resulting plant often exhibits hybrid vigor, growing larger or faster than its parents. However, this vigor comes at a cost. Seeds saved from a hybrid crop will not grow true to type in the next generation. Their genetic makeup is unstable, forcing farmers to purchase new seeds every single year. For generations, farmers were breeders. They saved the best seeds from their harvest, selecting for plants best adapted to local soil, local climate, local culture. These seeds, heirloom and open-pollinated varieties, co-evolved with their environment. Their deep, complex root systems formed symbiotic relationships with local soil microbes, creating a resilient and self-sufficient farming system. In contrast, hybrid seeds are often bred for performance in a high-input environment. Their root architecture may be shallower or less complex, designed to efficiently absorb synthetic fertilizers rather than forage for nutrients in a living soil. The soil is a community, and every member has a role. Large-scale hybrid monocultures can disrupt this community, silencing organisms that create fertility. Scientific studies show impacts. Research comparing soil under hybrid corn to soil under diverse prairie ecosystems shows declines in microbial biomass and declines in fungal diversity. A 2018 Science Advances study found modern corn breeding altered root exudates. Altered exudates have changed the soil microbiome composition, reducing the soil's ability to store carbon and to cycle essential nutrients like nitrogen, making crops more dependent on external chemical inputs. Earthworms, the intestines of the earth, are affected. They burrow, creating channels that improve aeration and water infiltration. They break down organic matter and excrete nutrient-rich casts. But systems accompanying many hybrid crops are hostile to earthworms. Shallower roots mean reduced organic matter, less food. Frequent tillage destroys burrows and can kill earthworms. Synthetic pesticides and fertilizers can be toxic, leading to declines. Mycorrhizal fungi form vast symbiotic networks, extending access to water and phosphorus in exchange for carbon. While hybrid genetics set potential, the farmer's practices determine the outcome for the soil. The seed does not exist in a vacuum. It is part of a system. Using ecological principles with hybrids keeps soil far healthier than following the full industrial prescription. Consider crop rotation. Monocropping the same hybrid year after year depletes nutrients, builds pests, and narrows soil biology. Rotate with legumes like clover and deep-rooted crops like alfalfa to feed a wider soil community. Plant cover crops to protect and feed soil year-round. Their roots hold soil together and provide continuous food for microbes and earthworms. Reduce or eliminate tillage so soil structure and life recover. Reintroduce organic matter, compost, manures, and reduce synthetic fertilizers. These choices give a balanced diet to the whole soil food web. The farmer's footprint can steer agriculture toward degradation or regeneration. The evidence is clear. The industrial model centered on hybrid monocultures and chemicals degrades living soil. It creates dependency, ecological simplification, and diminishing returns. Short-term boosts carry long-term ecological costs: biodiversity loss, compaction, depleted cycles, climate vulnerability. Solutions are practical. Diversify. Move away from monocultures. Embrace rotations and cover crops. Reduce tillage. Feed soil with organic matter. These practices restore fertility, cut inputs, build water resilience, increase biodiversity, and empower farmers. Farmers adopt regeneration. Policymakers and consumers support systems that work with nature. Save and share seeds. Breed open-pollinated, regionally adapted varieties. Reclaim the seed as a commons. The future isn't uniform hybrids over dead ground. It's rich, dark, living soil on biodiverse ecological farms.